Hi everyone, today we're going to be looking at how graphs can be used to show equivalent ratios and rates, and we're going to look at three different kinds of graphs. We're going to be looking at, well, tables, which is not a graph. We're going to use double number lines, which is a type of graph, and then regular graphs. So we're going to start by looking at this problem. It says Stephanie is driving her car to college at a steady rate of 50 miles per hour. That means she's using cruise control. The table here shows the ratio of time to distance. You'll notice that time is the top one, that is always the x-axis, and distance is the bottom one, so that's your y-axis. And the double number line shows the same data. So you will notice right here, you have time across the top, distance across the bottom. It has the exact same numbers that are shown here. And then down here we have a graph, and it also shows the same thing. Now I'm going to say one thing about this graph. Do you see these dotted lines? They are never actually shown on a graph. They are showing you how to plot it. If your 5th grade or 4th grade teacher told you to draw those lines, I will mark it wrong every single time. Do not draw those lines. Use your fingers, find your dot, put a dot there. Don't draw those dotted lines. They are incorrect in math class. Now, just like I said before, time is your x-axis and distance is your y-axis, so it's coming up and down. All three of these have the exact same information on it. So we're going to look at this question. How many miles can Stephanie drive in 6 hours? Well, we have 4 different ratios on the original graph. So in 6 hours, where would she go? Now, the thing that I like about the best about graphs is the fact that you can actually draw a line on your graph and you can extrapolate, which means predict in math, what it's going to be. When I draw the line, you will see I can come up to where 6 is, where it touches the line, and over, and it's 300 miles. So Stephanie can drive 300 miles in 6 hours. Graphs are great for this. So you can always draw a line on a graph and it gives you a prediction of what's happening in the future. So it wants us to determine how many miles Stephanie can drive in 7 hours. I forgot to type that. In 7 hours using each type of representation. So the first one, we are going to draw our line again so we can extrapolate. We're going to draw our line. Oops, I always draw it backwards. My point is at the wrong end. Oh well. And we're going to come up to 7, and we're going to come across, and you see it's 350. Okay, so let me change it to pen. We're going to come up and over, over, and we come out at 350. And so, according to my graph, my dot is at 350, and that is where we go. Now here, we want to figure out 7 hours. We have to ask ourselves, because this is kind of like a unit rate. 1, what do I have to do to get to 7? You're going to multiply by 7, right? So whatever I do to the numerator, I'm going to do the denominator. So I'm going to take 50 and also multiply it by 7, and I get 350 miles. Look at same answer. Double number line, we do the same kind of concept. We're going to do 5. And if you notice, these are all going up by 50 every time, so it's 250. 6 would be 300, and then 7 would be 350. Sorry, I have a hard time squishing everything in there. Okay, so now please remember, you guys are taking notes. You're writing these in your notebook. This is how graphs can be used to define ratios and rates, equivalent ratios and rates. So let's look at this one. This is an adult ticket price to Rollerville Amusement Park is $15, and the graphs show the adult ticket price, cost. It doesn't show anything else. What we're looking at now is this next one. It says it charges different for students and preschool age children. Students are $10, so we're going to come in here and we're going to fill this out. Guys, your first one is going to cost you $10. How much is 2 tickets going to cost? Oh wait, that would be $20. How much is 3 tickets going to cost? $30. How much is 4 tickets going to cost? $40. Preschool tickets are $5 each. So 1 ticket is $5, 2 tickets are $10, 3 tickets are $15, and 4 tickets are $20. Now, they want us to graph our points. So we are going to graph our points. First of all, I'm going to do this one. This is the adult ticket price. And I have colors. So you are going to sketch this graph in your notebook, and you are going to do the same thing. So I need to put points down. I have $1 and $10. Oh wait, I need to change that color. I don't want it pink. 1 and 10, 2 and 20, 3 and 30. If you do not have different colors, you can go ahead. 4 and 40. And use like a square or a triangle for each of these, and 5 and 50. Once you have that done, you're going to graph your line, and I'm going to change it to match, and then here is my next line, and you can see I can extrapolate or predict what's happening in the future using that line. Okay, now we're going to do the preschool tickets, so it's 1 and 5, 2 and 10, 3 and 15, and 4 and 20. Change back to my line, and we are going to use yellow, and we are going to draw our graph using yellow and what it would look like in the future. Okay, so that is how we can use a graph to predict or extrapolate an equivalent fraction or ratio. So if I asked you how much 5 would cost, you could go right up here and go, hey, look, $25 for preschool, 5 would cost $50 for students, and 5 would cost $75 for adults. So graphs are a great way to look at predictions or find equivalent ratios and fractions. Okay, so we're going to use a table to complete these measurements. Now, I actually did yearbook when I was back in school, and these are actually correct. It says pictures in yearbooks must be in a constant ratio of width to length of 2 to 3. So width is on the top, that's our x-axis, and y is on the bottom, length is on the bottom, that's our y-axis. So I have always xy, this is how it's going to look. If the table's this way, oops, it would be xy like this. That is how it's always done in math. You need to remember that. So 2 to 3, and I'm going to ask myself, what do I do to 3 to get to 6? I multiply by 2. So 2 times 2 is 4. And then you can look here and look, hey, look, there's a pattern. 2, 4, 6, what do you guys think this is? It is 8. And if you look at this, 3, 6, 9, 12, these are patterns. Now sometimes these skip, so you want to really make sure that the pattern holds true for the whole thing, but this does. So we're going to graph these. It says label the axes and plot the table values of our graph. So remember, the x-axis is always on the top, so this is our width, and our width is in centimeters. And then our length is our y-axis, and that is also in centimeters. And we are going to graph these points. So let me get a highlighter going. Okay. And I'm going to graph, these are 2, 4, 6, 8, 10. So these are by 2. So I need 2, 3. So I'm going to go up 2, and then it's in between. So it's in the middle, 3. 2, 4, up to 6, 2, 4, 6. Put it right there. Over to 6, 2, 4, 6, up to 9. 2, 4, 6, 8. In the middle is 9. Okay? Once I have 3 points, I'm going to be honest, 3 points is perfectly okay in math to go ahead and pull out your line. So we're going to draw our line, extrapolating up or predicting up to see what our values look like. And this is what your graph would look like. Please go ahead and sketch this in your notebook. You need to have this in your notebook. Okay, Augie burns 225 calories per 30 minutes of bicycling. Complete the table and chart of his calorie expenditure for different amounts of time. So it's the first thing they gave us was 225 calories. And remember, this is your X, this is your Y. Oh, I don't like that. They did not put that in order. They changed that. Oh, that's a bad math table. This is your X, this is your Y, and they should never do that. But we'll argue with the book later. So I'm going to go here to here because I don't want to divide by 3 right now. That's messy. So I'm going to go here to here, and I know that this is times 2, so I need to double this, and that's 450. Now, to go from 30 to 10, I do have to divide by 3, so I'm going to do that off to the side, and I get 7 subtract 15, 75. Now, because I have this number, I can go to this one over here. You have to kind of skip around on a graph like this, and I can go 10 times what is 50? Well, 10 times 5 is 50, and so I'm going to multiply this one by 5. This is not an easy graph because, first of all, they're out of order, and then you have to find different things. So 5 carry my 2, and I get 375. That's a 7. I don't know why it disappeared. And I have points. Now, it wants you to plot the value of your points, and we're going to do that. So I'm going to start with 10 and go up to 75. These are by 20, 40, 60, maybe 20, 40, 60. Nope, not that. 25, 50, 75. These are by 25. I had to figure out my scale, and it's okay to do that. The next one is 30, and I need to go to 225, so I go up to 200. One more. These are counting by 25, and that's going to give me that point. Then I'm going to go to 50 and go to 375, so going straight up to 300, 25, 50, 75, put my dot. 600, come straight up to 400, and go 25, 50, and put my last dot. Go ahead and graph your line, whoop, like so, and that gives you all the points in between. So there are some questions we need to ask. It says, how many minutes would he need to burn 150 calories? So 150 is here, 25, 50. I'm going to come back over, and I'm going to come down, and I realize it's going to take me 20 minutes to burn 150 calories. Now the next one says, how many calories can he burn if he bikes for 25 minutes? So we're going to go between 20 and 30, come straight up and go over, and you will see that he burns 200 calories in 25 minutes. Okay, this is our last problem we're going to be looking at. And it says, the 6th grade chorus made and sold their own mixture of trail mix at a basketball game to raise money for their upcoming trip. They sold 1-pound bags for $2.80. So here's our first bit of information we have. 1-pound bag was $2.80. They got many different requests to buy different size of trail mix. They decided to vary the size, but they want the ratio cost a pound to remain the same. So I'm going to do this 0.5 first because, you know, my brain, I like to do 280, and I need to know half of that. And I'll be honest, I can do this in my head, but I'm going to show you the division is 1.40. So it's $1.40. And the reason I did this one first is because now 0.25 is half of this one. So what's half of $1.40? And that's 70 cents. Now here's the cool thing. If I add these two together, I get 0.75. So my answer here is $2.10. And I'm just going to keep going, matching my numbers. I need 1.25. I'm going to add $2.80 and 70 cents to get $3.50. And then I'm going to add 1 pound and a half pound to get $4.20. Now I'm going to ask you to go ahead and create your own graph right now. And that is fine. You're going to draw that in your notebook, and I do want to check that in class tomorrow. So please go ahead and do so. I will see you guys in class tomorrow, and you have a great day.